Hi, I'm Angela, and I'll be speaking today about fairness, welfare, and equity in personalized pricing. This work is joint with Nathan Kallus at Cornell University and Cornell Tech. So a broad motivation for this paper is understanding what are the expected distributional consequences of price optimization, or what I'll call algorithmic pricing, or personalized pricing, covariate-based pricing, and so on. So how do we understand and measure who wins, who loses, informally speaking, in terms of kind of assessing disparities along membership in protected attribute groups such as race, gender, and so on. And so first I want to provide a little bit of summary of the regulatory context, which helps inform how to think about how these considerations arise in different kinds of application areas. And so I'll mention at the start that price discrimination, or simply charging different prices to different people, is not actually illegal per se. Nonetheless, in certain application areas such as insurance and lending, which are more strictly regulated by discrimination law. Of course, there are a number of concerns about price discrimination or price differentials and concerns from discrimination law. However, these price differentials and these settings often arise from negotiation of individuals with, for example, lending agents who have some discretionary leverage in making some amounts of discounts and so on. And so it's possible that price differentials in the setting arise due to either the differential ability or preparedness of customers to negotiate, or the individual level bias of pricing agents. And so in different application areas, such as value-based pricing, or kind of just the everyday kind of pricing that we interact with as we pay for goods and services, and in algorithmic settings where we try to predict the value of making a price offer by predicting a consumer's demand based on their covariates, there's a kind of generic cautious optimism that at a very intuitive level, low-income individuals may be more price sensitive, and therefore allowing for some degree of price optimization in the setting may increase access by allowing for making lower price offers to lower income individuals, and so on. And so this kind of generic optimism about personalized pricing is reflected in some of the canonical economic analysis and so on. There are also a lot of ancillary benefits of personalized pricing, such as price transparency, which leads to price competition and overall lower prices. But in this analysis, I'm not going to consider competition. I'm going to consider the pricing problem for a firm or social planner. And so I kind of mentioned this distinction because this analysis is going to mostly focus on value-based pricing. So not necessarily considering the concerns for discrimination that arise in those other settings, such as insurance and lending. And I'm also going to focus on metrics for fairness or welfare related to pricing that are observable. So I'm not going to assume that I have access to valuation distributions of consumers and so on. And sometimes this can be thought to correspond to the binary feedback model. So the data consists of information about customers and whether or not they purchase at certain prices. In particular, later on, I'm going to be interested in studying trade-offs between proposed possible parity constraints on revenue optimization. And kind of inductively from the literature, I hope to make an argument or showcase this example where, for the setting of goods with public externalities, personalized price offers may provide a kind of win-win situation by expanding access or increasing market share in a revenue-neutral, revenue-improving fashion. And so first, I want to talk about some related work, and I'm going to be very brief here and just talk about some very broad context. And so, of course, there's a lot of classical economic analysis of price discrimination. The kind of classical categorization is, on the one hand, we have first-degree price discrimination, where you price customers at their exact willingness to pay, which is assumed to be known. Or we could have second-degree price discrimination, which depends on the quantity that is purchased, but not the customer attribute, so bulk discounts. Or we could have third-degree price discrimination, different prices to different groups of customers based on some kind of coarsening of their information, so such as offering discounts to seniors or students at the movie theater. And so, broadly speaking, when I'm thinking about personalized pricing, I'm going to think about settings where we have finite covariates about an individual. And so the setting is something like very fine-grained third-degree pricing that is approximating first-degree pricing. And this is the kind of personalized targeting setting that is quite common in terms of e-commerce or internet targeting. And so in this classical framework, the notion of consumer welfare is essentially defined as a consumer's valuation minus the price they pay. And so the kind of non-ideal theorizing objection to kind of simply using this welfare analysis is the intuitive recognition that in real life, if we're estimating a so-called willingness to pay or valuation, estimating from the binary feedback data from how people purchase at certain prices, Well, given the patterns of income inequality in real life, individuals with different kinds of binding budget constraints will result in the fact that this data reflects more so an individual's ability to pay rather than their willingness to pay. So this is a kind of intuitive objection to leaning too much on assuming that valuation distributions are known, because in real life, the data we have reflects more so this ability to pay. And this can be formalized further, but this will just kind of motivate some of our focus on defining some of our metrics with respect to observable quantities. And again, with related work, there's also some quite comprehensive analysis from the point of view of tech policy or socio-technical analysis. And a lot of this situates personalized pricing or algorithmic pricing in relation to the analysis of privacy. And so I'm not going to consider privacy considerations in this analysis, but refer you to that other analysis. In relation to fairness and machine learning, I'm going to be interested in particular in the interaction between prediction and decision making. So on the one hand, I'm generically going to consider a prediction subproblem of estimating consumer demand at given covariates, but I'm going to be particularly interested in auditing the decision or the price that is the output of some optimization using that prediction. And relative to kind of fair division or more classical economic settings where optimal prices come with strong conceptual guarantees, those conceptual guarantees hold in an ideal sense, again, more often in narrowly bracketed settings that do satisfy, for example, that individuals have equal outcomes. And so, again, thinking in this kind of practical revenue management point of view, in terms of pricing in the wild, a kind of de facto assumption is that one of the challenges is that individuals do have unequal incomes at the outset, and this classical analysis of prices enacting optimal transfers or trades is not necessarily so relevant in this algorithmic revenue management setting. So in terms of notation, I'm going to use X to denote covariates, A, the protected attribute, which is going to be assumed to be binary thereafter, and the kind of subproblem of interest for covariate-based pricing is to estimate the personalized demand at some price. So D of P given X and A is the estimated demand at some price given covariates and the protected attribute. We're going to denote the per individual personalized price, P, which is some function of covariates and the protected attribute, although it could be a function of less than that information. Correspondingly, the revenue is simply the price times the demand realization, and a personalized pricing function optimizes the expected revenue for an individual at X and A. Okay, so I'll walk through some of the notions of fairness that are identified in this paper, and I'm going to try to provide some contextual justification before each one, or some context. And so pricing does a lot of things. So there are a number of different levers in this kind of optimization problem, and we may justifiably have different distributional preferences on different aspects of this problem. So we may have distributional preferences on prices because prices affect people's budgets, so it affects people's utility directly. And we may also consider conditional versions of this that reflect the fact that prices affect people only if they purchase at that price. And so, for example, there's this idea of the so-called pink tax, that women pay more for certain kinds of grooming products by virtue of gender, or one famous example is a pink razor, which costs more than a functionally identical razor that is not pink. And so I won't unpack this in too much detail, but if this seems objectionable, this motivates thinking about some kind of price parity across groups, so kind of equalizing the prices that are offered across individuals with certain protected attributes, perhaps regardless of the covariate distributions. And so a different notion recognizes that prices also induce allocations to a good, and we may have distributional preferences on equitable access to these beneficial resources, regardless of the underlying income differentials that could be driving the demand response. And so this motivates consideration of equal access or increasing access. A next consideration is that prices actually allocate goods to those with higher valuations. And so this is the sense in which dynamic pricing can be thought of as fair, because it allocates scarce available resources or capacity constrained resources to those with the highest valuations. And so this kind of fairness is often thought of as allocative efficiency, or the kind of targeting nature of prices. And so a last consideration that kind of, again, emerges inductively from the literature is recognizing that prices can allocate goods that themselves have effects on individuals. So why might governments be interested in personalized subsidies, or why might personalized prices help enact subsidies for these goods? Some examples of which are household finance, Microcredit and lending, healthcare, preventive health interventions, vaccines, and development economics, such as bed nets and so on. And so with these last two examples, the thing to consider is that a social planner might have some utility for individuals receiving the good, perhaps because the good itself has some long-term effect, but that long-term effect is not being appropriately endogenized by the individual consumer, perhaps because of various other kinds of budget constraints. And so this kind of motivates thinking about alternative downstream outcomes and thinking about targeting long-run dynamics directly. And so in particular, this kind of consideration can actually rationalize, for example, our interest in equalizing access in the first place. And so having introduced these notions of fairness or parity, we can also simply recognize that an opportunity to measure these aspects of the distribution of prices or market shares across groups and consider these differences as disparities. So we might be interested in assessing the distribution of prices across groups, so we can simply take averages. We might also check higher moments, but averages is a good way to start off with. Or we might simply take differences of the market share that is achieved by either group, and so on. And so again, these aren't really revolutionary observations, but the goal is to try to kind of map these different considerations and understand when we might be interested in these different kinds of notions. And so having done so, we can kind of introduce these into a kind of conceptual multi-objective program. So we start with kind of nominal revenue management. We can introduce additional objective functions such as the group conditional market shares, or the long-term outcomes themselves, subject to various kinds of parity constraints or even a kind of budget balance constraint for the firm. And again, this is more of a conceptual device. And in the analysis, I'm going to look at some trade-offs two at a time. And so the paper goes into more detail to try to introduce some different settings and try to inductively understand why these considerations come up with pricing in different settings. Just to summarize, a key observation is that different application areas activate different notions of fairness considerations. So the point of the paper is really not to kind of analyze the five-dimensional Pareto frontier of all these different notions, in particular because they're not going to be simultaneously relevant in any particular application. And so I'm going to start off by considering these trade-offs two at a time. So one thing to consider is, for example, marginal price parity. And so this simply introduces a constraint on the average price across groups on the revenue management problem. And so a kind of motivating question for this analysis is trying to understand what are the trade-offs between attribute-based or attribute-blind pricing schemes. To facilitate the analysis, I'm going to make some assumptions, namely that the demand is partially linear and that the price elasticities are normal in the sense that as price increases, the demand decreases. So I can now compute the attribute-based optimal fair price and the attribute-blind personalized fair price that does not use the protected attribute information itself. And so analyzing the ways in which these differ from the unconstrained optimal prices, essentially by the terms highlighted here, we can see that the attribute-based personalized price essentially has a group-based lump sum difference, whereas the attribute-blind personalized price does not vary in the group. So we already know by virtue of optimization that the attribute-blind personalized price achieves lower revenue. And to kind of try to understand which scheme would be preferable, there are some concerns with this attribute-based fair personalized price, because for an individual with fixed covariate X, then the price difference is being driven just by the protected attribute itself. And this can violate certain kinds of notions of individual level fairness. Nonetheless, making some simplifying assumptions that essentially correspond to assuming that price differentials are due only to differences in covariates between groups, then I can conclude that actually group B would uniformly prefer the attribute-based fair price in terms of just their preferences on the magnitude of the price. And for some individuals in group A, attribute-based pricing would also be preferred. So for some covariates, both groups would prefer the attribute-based scheme just in terms of the magnitude of the prices. And so going further, I can also try to analyze a kind of different set of notions. So the relationship between finite sample estimation and mispricing errors. And so identifying some possible estimation errors that reflect the finite sample uncertainty, I can consider a decomposition of the mispricing error. And essentially, the picture is not very clear. If these errors are all of the same sign, then we can conclude the direction of mispricing error, but generically we may not have reason to believe that they are all of the same sign. So there's some additional analysis in the paper on some of the additional notions of fairness that were mentioned, but I want to talk about some of the empirical, just the kind of empirical evidence, looking at some data sets where personalized pricing can help improve these market share considerations and so on. And so the first example is willingness to pay for an elective vaccine. So there's a survey in Sweden asking people about their willingness to pay for this elective vaccine for tick-based encephalitis. And the protected attribute, I'm going to allow to just be low versus high income. On the left, I have the revenue curves for simple group-based pricing. On the right, I show the distribution of optimal prices that arises when I consider a covariate-based pricing scheme. And so here, the group-based pricing scheme actually achieves less revenue, but it increases the market share, and this is because the minority group is what is called a weak market, so it has a low demand response, but the revenue curve does not have great second-order curvature, so we can actually decrease the price without incurring great losses in revenue. However, the covariate-based pricing scheme achieves more revenue than the uniform monopoly price, but it also achieves more market share than the group-based pricing. So we can increase access for the minority group in a kind of revenue balance or revenue optimal fashion. And so in this microcredit example, the previous example used a simple logistic regression model, and we simply optimized by enumeration over prices for every x. In this microcredit example, I'm going to take a look at possible non-parametric approaches to estimate what is the value of pricing these customers differently. And I can do this because the underlying data comes from a randomized controlled trial. So I'm just going to use a method for off-policy evaluation for continuous prices. The goal is to estimate the value of a learned. And then I'm going to kind of validate this out of sample by using a nuisance model to estimate the performance. And so on the left, I'm comparing the revenue achieved by constant interest rates against the revenue that is achieved by the personalized price. And so again, the personalized price increases revenue relative to various constant possible interest rates. More importantly is kind of understanding the targeting implications for the personalized price. So relative to various possible constant interest rates, here the dashed lines indicate the average market shares per group that are achieved by the personalized pricing allocation. The slanted lines essentially indicate the market share that arises, again, as these constant interest rates vary. And so what happens is that the personalized pricing allocation is able to achieve market shares that would have corresponded to lower interest rates for females and low-income individuals relative to the interest rates that correspond to the rate that is allocated, the rate that arises from the personalized allocation for the non-female and the non-low-income groups. So this increased capacity to change the pricing function allows for achieving different kinds of market shares and allowing for increasing the market share for the female and low-income groups while maintaining good revenue by increasing the prices for the non-targeted or the non-female and non-low-income groups. Okay, so I just wanted to conclude there. I discussed some of the taxonomizing analysis in this paper that motivates thinking about certain kinds of trade-offs, in particular with respect to covariates and protected attributes, how they affect the demand function, and how the price optimization depends on this covariate conditional and possibly protected attribute conditional predicted demand. Thank you.